can you see my slides?
Yes, sir. Yes, sir.
Sounds great. So this is pretty much a story, maybe a bedtime story for some of us, on how we build a scalable application security program using mainly open source and metrics where I work. So a couple of things about me. You can find me on Twitter for any feedback or more information. My nickname is 0xFD, and I work as an application security engineering lead at a startup that does core banking systems in financial technology. They're called Thought Machine, and by the way, my team is hiring, and Thought Machine is hiring. So if you want to join, the link is there, or talk to me. And I've been, but mainly I've been an OWASP volunteer for close to, oh God, it's 10 years now, isn't it? Yeah, for close to 10 years. I'm getting old, but we all are, right? And I want to start with a disclaimer. All opinions expressed are my own. The work was performed by a team. Most of the work was performed by a team. I don't lay any claim of this work only to me. And I want to thank everybody who has done all the previous work that we could use to do all this program. And a special thanks to my team and my colleagues for the feedback and for sitting through all the practice runs of this presentation, because there were a couple and they spent their time. So thank you, guys. So here's what we're gonna try to talk about. These 9 things, how they're called, it's not really important. The important thing is we will try to reference the software assurance maturity model and the maturity levels for each of these 9 work streams we did. Some is kind of generic, but it's the best mapping I could find. And I'm trying to reference some as much as possible so that we have a common ground to stand on. So we understand what the improvement was and what what the point of each work stream was. References are loosely mapped because some is quite common sense, and I'll go through this in a second. What we're not gonna talk about, because we only have 40 minutes and not 3 hours, is we're not only gonna talk about application security, no risk management, corporate certifications, dealing with clients, general corporate security, workstation hardening, no operational things as well. Like, so there is nothing about SOC, despite the fact that we build a SOC, right? Because we don't have a lot of time. And so let's begin, right? I joined Thought Machine about 2 years ago now. And when we joined like with 3 or 4 people. We found a company that had a pretty solid continuous integration. They had some common libraries for functional things. They were using some security user stories to build software, right? They loosely followed SAM, as in SAM is common sense, right? It says use the CI or deploy via continuous deployment, which for a startup nowadays is like, it's your bread and butter, right? Like you don't deploy software without Jenkins or some continuous deployment. So it doesn't really map cleanly, but I'll do my best to map it, right? So it loosely followed SAM. They had a super solid build system. It's called please.build. It's like Google's Bazel, but on steroids. It does everything. One of the better build systems out there. So when we joined, the company was, I think I interviewed when we were 60. I joined when we were 90. I was after a couple of months, so you can see the growth of the company. They used for languages. I think we still use only for languages. And we built microservices running on managed Kubernetes. And back then they were only using some linters, but they had a super solid secrets management based on HashiCorp Vault, right? And they were running opportunistic pen tests, and that was their security. So the security team was two very senior people, really, really good. But because it was two security people for a whole organization doing everything, the maturity was kind of all over. There were parts of some secured build that were maturity 2, right? So build process was optimized and fully integrated into the workflow. But requirements-driven testing was of maturity level 1 because it was opportunistic. Security testing was also level 1. Someone was running some SAST in Jenkins opportunistically. There was, again, some opportunistic pen testing. And security architecture was not exactly 1, but not exactly 2. So let's put it at 1.5, right? There were some common design patterns and some standard technology and frameworks. So we joined, and we were told from day one that scalability is like top priority. We are in growth mode. We're going to hire a lot of people. We're going to write a lot of software, a lot more of software. And generally, we need to scale. And we also decided that we need more visibility, right? Who is going to do what? What are the features that are coming in? We also figured that we need way better detection, right? Where are the skeletons in our collective closet? What software did we RAS? We are not a large bank where we can take time. We're not a large company in general where we can take time to deliver things. We are a startup. Next funding round depends on us getting a customer. Us getting a customer depends on us delivering some software, right? Things are going to be RAS. What is of low quality? What do we RAS? Also, we wanted better automation. As we all know, CPU time is cheap. Engineering time in New York, San Francisco, Oslo, London, definitely not cheap. So if we cannot afford to have people that just do one thing over and over. This is work for computers, right? And we wanted fewer defects found by customers. This is again on scalability. Every customer phone call that we have about defects, it's time we could be fixing root causes, right? We could be improving the product, not talking to customers on how to fix it. And also we wanted to measure everything so we know what we're doing, where we are, and how we're going. So we started with detection, right? So we started normally, we approached some vendors to buy some products, and at the same time, we used our build system to run some static code analysis. We used Dockerized tools that we got from GitHub or GitLab. As a hint, pentester repos are amazing for Dockerizing things. A lot of tools nowadays already come Dockerized as well, a lot of OWASP solutions as well. And one thing we did, which I think is important, is we ignored all the noisy rules so that we have low noise and we can get the feedback cycle quickly, right? And we also run an in-house pen test, so we understand what is this thing we're talking about, what is the product, what it does, where is the security, right? The general purpose was to copy the detection. The general purpose for SAST was to copy the detection out of our CI/CD and give us the ability to zoom in parts of the code, right? And find specific vulnerabilities that we wanted. And because of our amazing build system, we could run queries like, give me sources, libraries, configuration that builds like this binary service that does payment processing. Because in the end, you need to start from somewhere, and starting from a payments processor kind of makes sense at the time. So we used Bandit, GoSec, FindSec bugs, pip safety, dependency check, and other similar tools to give us a basic idea what's going on and where we should start from the pen test. So to integrate all the tools, it took about a week. Again, we used existing code. Then a month and a half, and you will see a lot of these slides. This is Gantt charts on what took how long. With solid color is how long the implementation took, at least until the proof of concept. And then the lighter color is how long it took us to measure, how many iterations of implementation, generally how long. And with dotted lines, dashed lines, I've marked something that became business as usual, and we still do. So it took us a week to integrate all the tools, then a month and a half to get meaningful and consistent results across the whole code base. And we were doing other tasks as well, right? So we revisited our detection after the first quarter, where we felt we had a solid grasp of what's going on. And of course, we continued this work stream as part of BAU nowadays, right? So what did we measure? We measured how many vulnerabilities, like true findings, we had per team. This is a bad way of measuring team security maturity. It is not very accurate, but at the beginning and for a quick feedback cycle, it was good enough. We also measured how many non-reproducible findings we had per team. By non-reproducible findings, I mean things like the tool is technically correct, you are concatenating SQL queries, which technically could be SQL injection, but seems you know what you're doing, or you got lucky and this is not exploitable, right? So this gave us generally two types of teams, either teams who are too cocky. We found a couple of teams who were building their own SQL query builders. They had some amazing engineers who were cocky, or teams that were better off. We had teams that were building query builders, but everything was piped through normal query builders first, so everything was safe. And we also tried to detect specific parts of the code base with significantly fewer findings than average. No findings for us means no visibility. So we needed to figure out if we need manual testing or better rules. It took a day to figure out if the sample of low signal code bases we had was due to either exceptional code or uninteresting code, right? Or due to missing rules, and we acted accordingly. So here's what we talked about in our retro. We felt that we spent too much time talking to vendors. We build things in a very interesting way. We have internal libraries, we have a custom build system. That means most vendors do require a lead time to integrate with us that is longer than usual. You don't just dump a solution in. And we were just starting, so we needed much faster feedback. So we couldn't really integrate with vendors, and we shouldn't have tried to talk to vendors in the first place. For the record, we are approaching vendors. We talk to vendors now that we're more mature, right? I think, and to reference some, I think with this, we reached security testing level 2. We were employing application-specific security testing automation, and we did the manual pen testing. As a result of this, after the first couple of weeks running detection and remediation, we got approached by engineering teams with questions about their designs. So we started adding alerts of what's coming in. Pretty much go to our planning software, add new alerts for new features planned, and block time to review the alerts and guess if the team will require input, right? Additions to a payment system are way more important than tiny new information on a static front-end page, right? The byproduct was that since we were at the beginning, we got really familiar with the company and who does what and which team is scheduled to do what, right? That improved our some security requirements. We didn't exactly reach level 2, but we had some structured security requirements available, right? And we were giving them to the team on a kind of on-demand basis. So here's the Gantt chart. Making the alerts took like an afternoon. And we revisited this work stream after 2 releases. And back then we had monthly releases. So what did we measure? We measured how often we guess correctly versus what is our overall features to figure out what we do, right? And how many meetings titled security input, that's how we were naming our meetings back then, resulted in actual new requirements, right? So initially, this was really bad. We had no idea about the company or the product, so it took us a while to get up to speed. But this matured massively with threat models, which is coming up. And speaking of coming up, I mean immediately after. Then after that, after figuring out that we didn't really understand a lot of the product, we appointed every single team lead. That was not democratic. We appointed every single team lead as a security champion. And we told them that they are free to appoint someone else if they are not available, right? We didn't want to waste their time. So we scheduled meetings with all security champions to do threat modeling. I think this is normal. It's pretty much an industry standard by now. I've linked some threat modeling advice from Microsoft and OWASP. They both have pretty solid documentation. As a bonus, we booked a 30-minute weekly meeting with champions to share updates. Think of it as a weekly stand-up, right? In the company, we call knowledge sharing sessions brown bags. So we instituted open presentations to talk about security stuff. We started talking about threat models. Then we talked about internal findings, and eventually we started talking also about industry news. Followed, there is a very popular security champion playbook and a very popular security champion presentation that I've linked. I think this advanced our some education level beyond 1, but didn't exactly reach 2. And our threat assessment level beyond 1, because we had threat modeling, but it's not every release, right? So the MVP, so initial threat models for each microservice, also an understanding of us, how we expect the system to be used, took 2 months to be of acceptable quality. And we measured and improved the process 3 months, so 3 releases, after we felt that threat models were of an acceptable quality. So they were going deep enough in the system. We measured the team understanding of the system, pretty much because we were presenting threat models, the presentation quality, right? And what we felt we knew about the system. We also measured other team participation in our brown bags, so how often other teams showed up. We measured coverage. We write microservices, so how many microservices are covered by threat modeling. That can be keyword matches. And also champion participation in most of the things, right? Like in our initiatives, threat modeling, brown bags, things like that. That was verbal and was pretty much an internal customer survey. How well do you feel champions participate in things? What did we improve? So because we had colleagues in our presentations, they corrected mistakes on the fly. So if a threat model had a mistake or one of us had a misconception about the product, we used this feedback to improve both our threat models and our understanding, right? The meeting, the 30-minute stand-up, was wasting everyone's time, so we made it into a questionnaire. Tell us if something is coming, give us a heads up. And we reserve the live meeting for significant changes. So if we need to debate about something. And we move the threat modeling responsibility to security champions and teams. This is because of scalability, small team, large engineering team, small security team, large engineering security team, large engineering team. I think that brings us to some threat assessment level 2. Because we had threat models that were updated by the champions automatically every release. Having done that and having a base level of security, we felt that we needed some training. So at the same time, we tried to improve culture. So we created a coding-focused AppSec training. We created a spot the bug type of game, pretty much a slide with buggy code. You have 10 seconds to look at it and give me the bug. It was super obvious bugs, wasn't something insane. And we also added a menu of services we can do. Pretty much talk to me if you want to pen test, code reviews, architecture reviews, things like that. Normal things. I think this is also kind of an industry standard. One thing we did, and I think it's important, is we emphasized that we will eventually mess up and there is no blame for vulnerabilities. Talk to us if you find something, even if you wrote it, it's not a problem. Our job is to fix it. You're not getting punished, right? And we made all this training mandatory for new engineering joiners, and we made it optional for everyone else. I think it's important. I think this brings us to some education level 1+. It's not exactly 2, but it's better than generic training. Some education level 2, I think, says that you need to have specific for your languages. It wasn't exhaustive for each language we were using, but it had generic nuances for most of our main languages, right? So modifying and creative, the training was a couple of days on and off, and then we measured after each iteration, but the retro was after 5 or 6 iterations, and this was also added to our BAU. What did we measure? We measured voluntary participation, pretty much how many non-new joiners were in the calendar invites. What was the engagement while on the training? Follow-up questions, interaction frequency with security champions if it improved, and what was, of course, our velocity loss because of the training, right? We don't want to be doing only training. So voluntary participation was always bad and still is bad. People were and are more likely to look at the slides, but the joiners participating in the training work as an advertisement for the training. So eventually we got most of the senior engineers to look at the slides, which was great, because a couple of them also found bugs, but that's a different thing. So engagement was all over the place. Some people were really engaging, where, as in any training, some are happy to be quiet. And follow-ups, of course, were mostly from high engagement individuals. Interaction with champions improved for the champions that actually took the training. And team velocity loss was quite minimal. Training, along with some time before and some time after, was about 90 minutes every 2 weeks. It's not really that bad. We can afford to lose 90 minutes from one person every 2 weeks. It's, if we are to train like tens of people, right? What did we improve? We adapted the slides very often. Pretty much every time we delivered the training, we added recent findings, we added better examples, we updated the menu as we added more services and more tools. But speaking of tools, running GoSec or FindSec bugs and having to triage everything, like thousands of results every single time, then copying the results manually to ticketing system takes kind of time, right? Also, every new tool you add to this pipeline, even with custom rules, increases the time you take. So because this is very slow, it burns out the team members kind of a lot if I have to spend a day, a week triaging the same things. So getting inspired by Coinbase and Netflix and a lot of others, we built a tool called Dracon. It's we've done a presentation in AppSec Amsterdam last year about it. It's a framework, runs on Kubernetes. It runs scanners and aggregates scanner results. Imagine CI/CD, but for security only. It has the advantage that it can mark a result as a false positive or a duplicate. You mark a result as a false positive, and then Dracon will ignore it. It can find duplicates. So you get false positives only once, which is important. And yeah, it runs a bunch of static analysis, dependency checking, dust, and dumps the results in flexible syncs. So if you want to have GoSec, go to Elasticsearch, but dependency check, go to Jira, you can do this. So we did that. It took us 3 months to write most of Dracon. Then we stopped for manual pen testing and some other activities. Pretty much we had the release. Then after that, we started again for a month, and 2 months after the release of Dracon, so about 2 software releases for us, We measured, what did we measure? We measured time to triage, pretty much, how fast after Dragon Run we had results, and and we used the frequency of team dropping SAST scans in favor of other tasks as a weak measure of how appealing SAST is now, and what's the burnout of the team running SAST, right? We found that SAST popularity increased, especially when we started dumping low noise pipeline results in Jira. Now it's a weekly 2-hour task for the security engineering on-call person. I think that brings us to security testing level 2.5. We're not exactly added in the development process. We still run weekly, and it's still best effort, but results are much easier to gather, right? In the retro, what did we talk about? It took us about 3 months of non-release time to get Dragon where we wanted it to be. If the business had reprioritized security in that quarter, it would have killed the project, and we would have lost all this time, right? So starting smaller from SonarQube or similar, and then building on top of that would have been faster on the short term. It was a bet that would have backfired, but luckily the team is amazing, and we managed to do it. We have a couple of really good backend engineers who managed to deliver super fast. By the way, Dragon, as I said, is open source now. You can find it in the Thought Machine GitHub. You can start using it now. You do not need the 3-month lead time to do flexible static code analysis.
I already put it in the chat window. So
FYI,
I put it in the chat window for everyone, the GitHub.
Oh, thank you, Guy. Yeah, that's great.
It's already there.
Awesome. So SAST Dragon was almost too efficient. We started getting complaints from teams that we are overloading them with vulnerabilities, which was not great. So we started a vulnerability management program, because before that we were just a startup, right? Like we were just opening a small ticket or sending them an email or a Slack message if we thought that was fast, or even giving them a pull request to fix something. But with so many results, we needed a better vulnerability management program. So we started using Defect Dojo, great project from OWASP. And there was someone in AppSec California that delivered a great presentation on vulnerability management in Jira. We copied most of the presentation kind of verbatim and iterated on it. This took us, so installing Defect Dojo took us about a week. We had to rewrite its Kubernetes manifests. Then another couple of weeks took us to experiment with Jira and figure out what data we wanted. And then after establishing the vulnerability process, which was, we measured when we didn't have any changes for about a couple of weeks. So we felt it was stable. So nobody felt the need to touch it. What did we measure? We measured normal vulnerability process stuff, pretty much average time for a vulnerability being in development, and outliers. So what's the staleness of vulnerabilities per team and component? Which teams are likely to have trouble fixing things, and also how often classes of vulnerabilities appear per team or component. So for example, we found that we would get a lot of value if we introduce some Terraform changes, right? Because we wanted to know where are technological gaps, which technologies we need to master. And Terraform, for example, was one of them, which brought us to some defect management level 1, have a vulnerability management process. So what did we talk about in the retro? We spent a ton of time fine-tuning for optional data. It was a bad idea. We kept going back to Jira and changing and gathering more data and adding more fields and changing the fields. And it felt at the time nice because we were getting all this nice data that we could potentially measure, but it costed us time. It also costed us time figuring permissions. We started going way too deep into corporate certifications and thinking things like, oh, only security teams should be able to triage, or only security teams should be able to move the vulnerability ticket in that state, which at the beginning, you just need a vulnerability management process. You do not need a complete vulnerability management process, right? We should have started with small vulnerability tickets, 5 things, and iterated, which we eventually did. But yeah, anyway, and then introducing Defect Dojo for us did not work. It gave us 2 sources of truth. Defect Dojo has this great feature where it can sync to Jira, but we couldn't use that. So in the end, we ended up with 1,000 vulnerability findings, indications in Defect Dojo, and 5 vulnerabilities in Jira, and having no way to cross-reference them unless we did it manually, which gave us 2 sources of truth. Not great, but it has a great API for integrating. So if you can link it to Jira, perhaps a good idea. So what did we improve? We improved the metadata we gathered. We cut it down by a lot, and we ditched Defect Dojo. Sadly, great tool, but not great for us. Now, if it's not in Jira, it doesn't exist. As an anecdote, yes, my opinion, you can technically track corporate risk in Jira with filters and special epic tickets that link to vulnerabilities. It has worked better for me than doing it over spreadsheets because it can be automated. Yeah, but having a vulnerability process, we went back to sort of training, but not exactly training. So what we did, we introduced 1 night a month where we gathered together in a meeting room, bought pizza. We already have a beer fridge, so open the beer fridge, and drank beer, ate pizza, and played the CTF. We used already solved CTF challenges so that we don't get stuck solving them, but we learn the technologies and the vulnerabilities behind them, right? And of course, we focused on CTFs with similar technology to us. As a bonus, after a while, when we built like some expertise, we built internal CTFs that ran for a week to raise awareness. It was custom-built applications on our internal technology stack, so they are super useful to us. And of course, we showed up in other teams' brown bags to present security concepts relevant to the team. So we have a team that writes GraphQL. We went there and talked about GraphQL internals, right? This is not in sum, but it helped us significantly. And one thing I want to say is that we started with open source CTFs and we moved to paid labs after a while, because setting up things in cloud environments, especially VMs in AWS or GCP, not great. They don't like you using their virtualization platform to run your own virtualization, which makes sense. So CTFs with green at the end was a monthly thing, hence not really consistent effort. We measured after the second CTF and kept adding up positive and negative experiences in our team's retros as they came. What did we measure? We measured participation. So how many people are security champions? How many people are not security champions? Seniors, juniors, stuff like that. We took that from the calendar invites and our memory. Not very accurate, but it gave us a good indication. And we also measured security performance of individuals and teams that showed up versus teams that didn't show up. As an anecdote, people, mainly champions, were very likely to drag along other team members, sometimes almost by force, like going to someone's desk, grabbing them, like, hey, come have a beer. It was great, and it worked nice for both for team building and security learning. And we spent most of our time during CTFs walking others through challenges or pair hacking than working on it ourselves. It gave us really nice opportunities to draw some parallels with some past bugs that we found and almost threat model our product based on the technology of the challenge. It was pretty good. So at the retro, we talked about how building custom CTF challenges, who would have thought, takes a lot of time. So that's why we changed to commercial labs. But we should have started from commercial labs. Building CTFs is really fun. I really enjoy doing it, but yeah, it takes a lot of nights and weekends. One of the positive was that there were several oh crap times when engineers found like super serious vulnerabilities in the product or 0 days in some of the libraries I was using, which was fantastic. We also figured several like low-level vulnerabilities when people found like bad behaviors that their team does or bad designs that someone did like 2 years ago. And they ran back to fix them, which was great. So after that, we felt that we needed more visibility. So we did something super simple. We got inspired by, there is an OWASP project called the Security Knowledge Framework developed by these two people in Central Europe. And it has a sprint feature that, based on ASVS, gives you a questionnaire on have you thought about X security things. So inspired by that, we added these 3 questions to every single epic that gets generated for every single feature of the product. So the questions are pretty much, do you need help? And the 2 most basic threat modeling questions, how can your change be abused and what have you done to prevent that? I think this is called some security requirements 2. Doesn't cleanly map, but it's close. Of course, it took us an afternoon to find correct phrasing and add it to Jira. We got in kind of a positive feedback loop by getting people to ask for enough people to ask for help so that we didn't measure enough. So we measured like after a year or anyway, several quarters. Yeah, I have here a quarter and a bit. So bad practice, but what can you do? So what did we measure? We measured positive responses over all tickets, how many questionnaire tickets were closed early in the epic versus late in the epic. So how often these questions were considered first versus last. What was the response time in case somebody asked for help? And of course, we ran a customer satisfaction survey to figure if this is what the engineering teams believe. Data and feedback showed that this was a terrible idea, like really bad for us. 90% of the tickets did not require any help. Because hindsight 2020, obviously, if you are building something that is security sensitive, you're going to assign it to your senior engineers who are going to rely on certain libraries that are coded correctly and security reviewed already, and they're going to use secure defaults. These people are smart. They know what they're doing. Most of the people that did want help preferred either immediacy of like some instant messaging like Slack or even coming to your desk, or asking via email because then they could CC most of their teams, right, or other stakeholders. And also by the time the feature had reached Jira, the team had already designed it, they knew how they're gonna build it, and it was only a matter of coding. So stopping to ask for security help or security retrofitting, not great. They prefer to talk to us during pen test phases or QA. We already had the visibility of what is coming, and we were doing some great work there, but we really hope that these tickets would help with kind of implementation security, but it didn't work. So retro, it trained users to click, Windows style when you get an error and you just keep clicking on it. Yeah, I understand that like there is no SSL on this website. It's fine. I'm gonna log on Facebook without it. And because they needed to keep working. Most features in a company, let's face it, are not of sensitive nature. You're going to have 5 big changes to your payment system and 100 like color or position changes to your CSS. So most people get trained to do their own thing. So what did we do? We moved to a similar questionnaire earlier in the feature cycle. Pretty much, we changed the alerts from what's coming in to a questionnaire. And another bad thing we did, we measured late. I've seen this working in other places, by the way. It's not bad in general. It's just a bad idea for our use case. And moving on, at some time later in the same year, we got inspired by Zap and JuSoap. We were at that time we were trying to run some CTFs, and we saw that JuSoap has a solving JuSoap with Zap training. So we thought it would be good to use it in the company. So we adjusted most of the slides to account for some of our past vulnerabilities. Instead of solving only JuSoap, we added slides for solving our product. And we started offering it to people on demand. I think that brings us on some training level 2, because we had very specific training for us. It took roughly 2 weeks of downtime to create the training. It was on demand, so it wasn't very frequent. And we measured results almost after every training. Mainly because it was like so infrequent. What did we measure? We measured team performance before the training, and then after a while measured the team performance after the training, so how many vulnerabilities we found. And we were asking the team for feedback, what can we improve, things like that. One significant improvement that we got from our QA lead was that Zap is not this arcane thing called an intercepting proxy, because most people have no idea what an intercepting proxy is. Zap is the best web debugger out there. It just debugs web requests. You don't need to complicate things. And this is my definition of Zap to this day. In our retro, eventually the face-to-face training was put on hold. Thanks, COVID. Really appreciate that. And because of the pandemic, the company bought a corporate subscription to a training hub that has similar resources. Of course, we're not the very first people to think of attacking GraphQL or Kubernetes microservices using web technologies. Others have had this idea and have been paid to make this training, so we shelved it. However, one thing that we started because shortly after the training was a thing called knowledge base. So SKF and OWASP have this thing called cheat sheets, small like knowledge bites almost, that show you how to write code in a secure way. So we created a knowledge base based on SKF and cheat sheets. Initially, we almost copied it. Then we got security champions to help customize them. I think that brings us to some architecture level 3. It says establish common design patterns and security solutions for adoption. I think that's it. And then this took us about a month, and it took us 3.5 months to measure. And we continued this to this day. What did we measure? We measured how many page views we have in our knowledge bases. Since we put the knowledge base on a wiki, Confluence, this is really good for this. And we also did opportunistic customer satisfaction surveys. So every time we talk to teams, we were asking, like, is this specific knowledge base relevant to your technology stack? Can we make it any more relevant? Things like that. Retrospective, and I think this is important. At the beginning, we limited edits to the application security team because, apparently only AppSec knows about security. And we created it under our space for convenience. As a result, very few people knew that it existed. So very few people read it. Eventually, we integrated into the engineering knowledge base per team. We should have done this much earlier, and it would have been so worth the extra effort. And going forward, being mindful of time, after we had a decent amount of training, a decent amount of threat modeling requirements, a little bit of everything, we thought that we should revisit testing. So we created this practice, policy, and then practice of running internal full scope pen tests every significant release or every 6 months, because we found that the company writes software quite fast. And then external pen tests every major release, so every big number release, I guess, or at most every year. We did, this is on top of the per release small pen tests for every feature, right? Sometimes features integrate in a way that is not obvious, so you need a full scope pen test once in a while on top of your normal pen tests. We also run retrospectives after every single pen test to figure out how the pen test went. And we did brown bags pretty much presentations on how we did the pen tests and what we find for every single person. Testing took 3 quarters, I think. No, 2.5 quarters. So 1 semester pretty much and 1 major release. We measured immediately after the second iteration so that we have a basic idea if these improvements were worth it. What did we measure? We measured how many bugs were found every test per team. We found a lot of bugs, not only vulnerabilities, but also product legitimate bugs, right? Something returning something that you cannot use in a malicious way, but it's not according to spec. We measured also how many bugs we found externally versus internally. What was the time spent testing versus vulnerabilities. We also ran a customer satisfaction survey with engineers, which are our clients, right? Our customers. So how do they feel if we did a good job, and do we feel we did a good job, right? And also, do development teams expect these issues? Time to fix issues and other tickets delivered on months that we did pen tests. So we find how much it slows us down. I think it's a lot, but it's worth it. And on the retro, at the beginning, we did not think about sharing much information about pen tests with external pen testers. As a result, they found fewer things than we expected. So now we share threat models and our walk through the application and its features, plus some hints on what we think is a hot topic in the application with external pen testers. So we improve their understanding and what they find. And getting closer to the finish. Because we found so many bugs, we overwhelmed development teams with vulnerabilities again. So we needed to improve our vulnerability management process. So we attached SLAs. We sent automated reports to directors, team leads, pretty much anyone who wants to get them. We also got some great TPMs to create manual weekly vulnerability reports that are curated and have some learnings from what its vulnerability metric means. And we also got engineers who fix vulnerabilities, or us if we fix something, to write regression tests for everything that they fix and tag it as a regression test for vulnerability X, so we can always test for this vulnerability and never have it again, hopefully. So I think that brings us to some defect management, like 2, and requirement-driven testing 2. We had so we had some test cases from requirements and some abuse cases at the beginning, but because of regression testing as part of the vulnerability management, I think we went up a level. This took us about a month of downtime to create a dashboard, automate report generation, learn about Data Studio, and get all stakeholders in agreement. Measure the quarter about the quarter. After that, it's not the fast feedback cycle, but we were doing other things in the meantime, as you can see here. So, what did we measure? We measured SLA lapses. We measured how many people accepted risk because they couldn't meet the SLA. We ran a customer satisfaction survey again. And what is the team effort on chasing vulnerability remediation and frequency of saying, oh, this is not a high, this is a medium, or this is not a medium, this is a critical, things like that. Pretty much. What did we improve? We improved our SLAs since they were quite draconian, and the process for risk acceptance, which was also quite strict. In the retro, we talked about how the process was driven by security, which makes sense. It was a vulnerability management process. However, on this, and we communicated results and requirements, not why we need these and not how to deliver them. Classic mistake. We spent a ton of time chasing teams to promptly fix vulnerabilities they didn't think were important. And this was quite improved when we explained why we have an SLA of like X days for X criticality vulnerability. So people need to drop everything they're doing and get on fixing like a critical, right? We also assumed that team members would triage everything the same way. Turns out this is not true. Different people have completely different context and completely different opinions for different things. So in the end, we wrote vulnerability triaging guides with very specific examples, business use case, and context documentation, which help bring some order to the initial chaos. Which brings us to now. What we're doing now, pretty much what we did last couple of months, and what I'm gonna give my boss as a roadmap. We are productionizing pen testing scripts. After so much pen testing, we have a ton of pen testing scripts, and we're making them of better quality and not pen tester written Python to run as post-merge tests. This is authentication authorization checkers, some basic injections and fuzzing, and some previously found logic errors that we think are technically possible to happen again. So maybe not have regression tests, things like that. And we're also improving our dust experiments. Somebody mentioned proxying tests through ZAP. That's great. ZAP has a lot more functionality if you script it, so you can really do magic with it. And yeah, this is our tooling. It has taken us a quarter. It's gonna take us more because, as you see, we have quite a lot of established work streams already. What are we measuring? We're measuring what's the time to develop and maintain versus the things it finds. If it's not useful anymore, perhaps we should drop it. What's the time to onboard new tools versus how useful we think they are. So for example, for Dust, missing headers, not really relevant. If I have a Dust, for example, ZAP, that can do JWT bypasses, that's amazing, right? We haven't done a retro yet because it's work in progress. Having said that, GraphQL is a pain to test against. And we have significant GraphQL. And the nice folks who are writing in QL need to give it some more features so that it does nested queries. But yeah, so far this workstream is going so good. Coming up next, literally what I've put in my roadmap, we're improving per team SAS rules, better static analysis for specific teams and how they work. We are adding more tools. I was telling Guy and Zoe that we're using SemGrep for some very specific things. We want to mature Dust so that we're not the only ones running it. We want to run Dust as self-service. somebody in Netflix has said that most of their security is based around secure defaults and common libraries, and I fully agree with them. That's how it should be. So we are adding more common libraries on where we find gaps. We're launching an internal bug bounty. At some point, I will talk about this when we have metrics from it. And we want to give some general threat modeling training to everybody, not just security champions. And we're going to use elevation of privilege. It's Adam Shostak's game, threat hunters or OWASP cornucopia for it. We haven't decided yet. And maybe we'll do some fuzzing. This is security team fun. It's not fast iteration, but it is really interesting. So if by some miracle we manage to deliver all the rest, fuzzing is definitely on the table. So that's what we will measure, pretty much like industry standards, lead time, customer satisfactions, things like that. Also team slowdown for tool introduced, and also team burnout for the tools introduced. We don't want to get people working on the tools or just writing same grep rules day in, day out. Does not make much sense. And with that, here's a summary of what we did, how long it took, and roughly when we measured results. As you see, there were several concurrent work streams. When you work in a small startup or a large company, I guess, you cannot just focus on one thing, and it makes sense. And that's what we did on the second year. Less things, but more established work streams. Here's our results. In the end, we followed mostly best practices, but there were cases where we went the extra mile and created new things. For example, Dracon, extra trainings, things like that. So, for example, some secure build, the build was already secure. We couldn't add much, but we could improve requirements-driven testing. So we added cheat sheets. We could improve security testing significantly. So we did all this process of testing every few releases and every few features. We didn't have any threat assessment, so we built it and we made it happen automatically every release, human automatically. We created the vulnerability management process that is followed and has SLAs, which are measured and tracked. We improved our security architecture. We improved our education and guidance. We improved the security requirements by a little bit. And we improved our strategy and metrics. I want to say quite a lot. Probably, I think I'm right. And takeaways. So what I've noted in my journal from these past 2 years, AppSec is definitely not the police. We are the team doctor. We're not there to maintain any order. We're there to advise and design a healthy and attainable lifestyle, right? We're not going to punish you for anything. We are consultants. Build systems are your friend. In multi-technology environments, they bring order. Multi-tech environments are usually chaotic. A build system is amazing at bringing order. Just having the ability to reverse query any dependencies makes sense. Having owner files in the code, so I don't need to chase when someone left the team or where they are now, makes sense. Building individual components is convenient. Some vendors have a long integration effort, sadly. Long-term makes sense. Fast iterations, not really. Training and culture is important. Allows people to understand why they're doing things, plus makes them passionate about doing them. Also, you seldom have unique problems. Like I've linked a ton of things in this presentation, right? The security community, luckily, is one of the most open ones I've known. Our generic solution is always out there. Someone else has the same problem. You should talk to them, adapt their solution. Speaking of adapting, you don't have to start from scratch. Get something generic in, iterate, right? Generic solutions are fast. Something is better than nothing usually, and other sophisms. However, generic things are not tailored to you. This will cause you to backtrack. So you need to embrace your mistakes, backtrack a lot. Eventually, you will end up somewhere that is better than where you were, right? also measure everything. It doesn't have to be automated. We started with wanting to automate all the metrics, didn't really work. So retrospectives are usually really good. That saved us a lot of time, and our main regret is that we didn't measure fast enough for a lot of things. So thank you, people. At this point, I want to iterate that we are hiring. If you liked what you heard, let's get in touch and figure something out. Put in the presentation some really great people that do really great job. Cloud Checklist, Marco does some great job. Clint with TLDR Sec, Tanya with CHACS Purple, the folks from Cloudflare, Dropbox, Square, Security Weekly, OWASP Melbourne has a whole series on what I talked about. Also, for getting metrics out of Jira, there is this fantastic library, Go Jira, and similar for Go Confluence. Does magic. And that's all from me. I will share the presentation, so probably I will definitely share a version of this presentation with the links, and so you can click on them and find out what's going on. And that's all from me. Any questions?